Page 2. So now, some of you may have trouble factoring a cubic here. This one, I made it so that it's pretty easy to do. There's an x in each term, so you could take that out, and we'd have x times x squared plus 5x plus 6. If I factor out, undistribute the x. The denominator should know how to factor that already. That's x plus 3 and x minus 1. We get the negative 3. We get 3x, excuse me, 3x and minus 1x is 2x and x squared. And the numerator here factors, so we'll get x, and to get 5, I got to be both adding, so I'll have to do something that multiplies to be 6 and adds to be 5. That's 2 and 3, so x plus 2, x plus 3 over x plus 3, x minus 1. So, first thing I notice, got a common factor here in the numerator and the denominator. That's saying there is a whole. So that's part C. C. Is there a whole? Yes. At x equal minus 3. And now to find what the whole is, I'm going to use the equivalent form, the one that will go right through the whole. This one has a hole because of that, but if I reduce it, get rid of those two, I've got x times x plus 2 over x minus 1. And if I put minus 3 in here, I get negative 3 times negative 1 over negative 4. So that's 3 over negative 4, or negative 3/4. That's where the whole is. But what's the A? Vertical asymptotes. Well, can't divide by 0. So this function cannot go through negative 3. Well, we already determined that's a whole. It's not an asymptote. But it can't be 1. So x cannot be 1, so there's a vertical asymptote at 1. And it's a line. And so we need to write the equation of it. Okay? Determine if there's a horizontal or slant asymptotes. Now the rule says that if the degree of the numerator is less than the denominator, it's a horizontal at 0. If the degree of the numerator is the same as the degree of the denominator, it's the ratio of the leading coefficients. Y equals, in this case, would be 1 to 1. But we don't have equal the degrees or the numerator less than the denominator. We have the numerators 1 more than the denominator. So that means we're going to have a slant or oblique asymptote. And you can find that either by dividing this into there. I'll do that, and then I'll show you a shorter version. So I got to take x to the third plus 5x squared plus 6x and divide it by x squared plus 2x minus 3. X times x squared makes x to the third. X times 2x is plus 2x squared. X times a negative 3 is negative 3x. Draw the line, change the signs. Add, that's 0. Add, that's 3x squared. And those happen to be like terms, so that's plus 9x. What times x squared is 3x squared, and that'd be plus 3. So I get 3x squared plus 6x minus 9. Draw the line, change the signs, and I get 0. I get 3x plus 9. I can't multiply x squared by something to get 3x, so I put my remainder 3x plus 9 over what I'm dividing by, x squared plus 2x minus 3. This goes to 0. degree of the numerator is less than the denominator, so this is going to go to 0. But this is still there, this line, so it's going to be a slant asymptote of y equals x plus 3. Now that was the long version. This is going to have the same slant asymptote, and since this is a single monomial, I could have used synthetic division. See what makes that be 0? 1, and put that into what I have in the numerator, which is 1x squared plus 2x plus no constant. If you multiply that out, you get x squared plus 2x. 1x squared, 2x, and nothing. So 1 plus 0 is 1, times 1 is 1. 3 times 1 is 3, and I get 3. There's my remainder, and there's my answer. 1x plus 3 for the oblique or slant asymptote, and I have 3 over what I was dividing by, 3 over x minus 1, which is what this will reduce to, because you could factor out a 3 and you'd have x plus 1. 3 times x plus 3, excuse me, and the denominator factors to x minus 1 and x plus 3. And those cancel, and I get that as the remainder. So anyway, either one of those would be good enough to show what the slant or oblique asymptote. Now it says find the intercepts. If I let x be 0, I find y-intercepts. And if I put 0 in the numerator of this, I get 0, 0, 0 over 0, 0, negative 3. I got 0 over negative 3, which is 0. There's the y-intercept. x0, we find the y-intercept. Now if I put 0 in for the y, I should get x-intercepts. Well, if I put 0 on this side, 0, then I have 0 equals a fraction, rational function, and the only way for a fraction to be 0 is if the numerator is 0. So if I look at the factored form of the numerator, 0 would make it 0, and negative 2 would make it 0, and negative 3 would make it 0, but the denominator would also be 0, so there is no value, so that's a whole. So I don't get to put in negative 3, just these two for the x-intercepts. So I'm getting more and more information about this, and there's one more piece that I should collect. And if I have a vertical asymptote, I should see what it does at the vertical asymptote. Now the vertical asymptote is at x equal 1 because of this factor. And since it's a single factor, not squared or cubed or anything, since it's a single one, then the graph has to go either both positive and they go opposite directions on either side of the vertical asymptote. So I'm going to check close to it, and I can use the reduced form, and I'm going to put in something close to negative to 1 where the vertical asymptote is. I'm going to put in 1.1 into x and x plus 2 and x minus 1. But I'm only going to do it, since I'm lazy and I don't want to do all the calculations, I'm just going to see roughly where it is. If I put 1.1 in there, this is a positive term. This would be positive. And 1.1, that would be positive. This would only be 0.1, and this is going to be bigger. So 0.1, a small number into a big number, is going to be big and positive. So on the positive side, on the 1.1 side, on the right side of the vertical asymptote, it's headed positive. And since it's a single factor, it has to be going negative on the other side. This tells me the positive side. Now I could have put in something close to 1, but on the left side, like 0.9. 0.9 would be positive, 0.9 would be positive, 0.9 in this would be negative. and it would tell me it's going negative. So I could have checked both sides, but since I know that it has to go opposite already, checking one side is enough, and so I can say it goes down on left and up on right. So, oops, sorry, that might have been off there. Goes down on the left and up on the right. So now I have a lot of information to draw my graph. So I'm going to put a line through here. Some of you don't like to draw the x-axis, and it really bothers me when you can't draw the line for the x-axis and the y-axis so we can see where they're at. And of course it bothers me if you don't put units on. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I made the grid for you. You should be able to put at least some units and they label the x and y axis. So let's go through. A, vertical asymptote at 1. B, oblique or slant asymptote at y equals x plus 3. Goes through 3 with a slope of 1. Okay? So when x gets really large, it has to get close to this line. When it gets really small on the negative side, it has to get close to this line. We know C that it goes through -3, -3/4, which is right there. It wants to go to it, but there's a hole right there. So it connects to it, but there's a hole. And then it has a y-intercept of 0, 0, an x-intercept of 0, 0, and an x-intercept of -2. Well, that nicely lines up with this, and it has to get closer and closer to this line as it goes out. Doesn't stay on this line, it comes back down, so it must come back down through there, and it goes towards the negative asymptotically towards that asymptote, so it must go down here, and since it's in here, it must be up here and symmetric, so down 4/1, up 4/1, it must go through there, down 4/3, up 4/3, must go through there, so it must come asymptotic there and there. No hole on that side. So that would be the graph. You can label things on here if you wish. That would be helpful. This is -3, -3/4. That might help some of you not make mistakes on this. -2, 0, 0, 0, and yeah. That gets most of the information on there. Well, we can put on y equals x plus 3 is the slant asymptote, and x equals 1. Okay, last ones here. A 4th degree, so it's got to have x to the 4th. Has zeros of 3, so that means x minus 3 is a factor. -5, so x plus 5 is a factor. 1 minus 2i, so x minus 1 minus 2i is a factor. And if that's an imaginary, they always come in pairs with a real coefficient. So polynomials have real coefficients, so then it has to be x minus the other one, and it comes out the conjugate of this, which is 1 plus 2i. There could be a number in front of there, but I didn't give you any information to find it, so that's good enough. It'll go through those intercepts. If you wanted to get extra credit, you can multiply this out Let's multiply the imaginary parts first just for practice here. X times x is x squared. X times this thing is going to be x plus 2xi. But x times this one is going to be x minus 2xi. So the 2xi's are going to cancel. I'm going to get a minus x, and a minus x is minus 2x. And then I'm going to have these two things multiplied, and this is going to be a negative times a negative is going to be positive, and I'm going to have 1 times 1, which is 1, plus 2i minus 2i, and then minus 2 times plus 2 is minus 4i squared. Minus 4i squared, I squared is negative 1, so negative 4 times negative 1 is 4. Oh, and I had 1 also. I had 1 plus 4, which is 5. There we go. Now I can check and make sure I got that right. I can pull out my calculator, and I can quit, and I can use the quadratic formula, which I've started before, and put in 1 and negative 2 and 5. And it says 1 plus 2i and 1 minus 2i are the two zeros. And if you're having trouble doing that, you may not have it in imaginary numbers. You may have it in real, so you have to make sure it's in imaginary. Okay. Now, this multiplies out to be x squared plus 5x minus 3x is plus 2x minus 15. And then I can continue multiplying here, but I think the rest of this is pretty easy for you to do. That'd be x to the 4th. Well, let's just do it. X to the 4th. We're going to have minus 2x to the 3rd plus 2x to the 3rd. So they're going to cancel. Excuse me. Oh, got the yawns. And then I'm going to have 5x squared minus 15x squared, which is minus 10x squared together, plus a minus 4x squared, so that's minus 14x squared. And then I'm going to have x's, I'm going to have 10x and plus 30x is plus 40x minus 75. Let's see if that is correct. We can do that by going to y equals, turn this one off. Actually, I'll just clear it. And I'll clear the other one. And I'm going to go up here and type in what I got. X to the 4th minus 14x squared plus 40x subtract 75. And if I graph, let's see, on Zoom 4, I'm hoping I see it cross at positive 3 and negative 5. Oh, can't see it down there, so I'll do Zoom 6, negative 5, positive 3, and then there's the two imaginary that you won't see. So this still checks, so I must have done it, not made too many errors in this, and so that looks pretty good. Now for the final one, solve this. Now I really don't even need a calculator, but I could put it up there. But this says it's going to be a graph that goes through minus 1. Well, it's actually going to bounce because it's a double, so it's either going to be at the top or bottom. This goes through 1, and that one's a single factor, so it's either going to go through down or going up, and it's going to go through minus 3, either down or up. And if I look at this, This is always positive. This is going to be x squared times a negative x times an x. So I'm going to have x squared times negative x. I'm going to have x to the fourth with a negative. The fourth has both sides going up or both sides going down, but with a negative, they both got to go down. So it's got to come up through negative 3, bounce at negative 1, and back down through 1. Now, when is this? This is what I put in for the y to get this graph. There is no y in this, but if I make this be y in the calculator and graph it, when is this stuff going to be greater than or equal to 0? That's when the y values are greater than or equal to 0. For all of this, it's greater than or equal to 0, all the way from negative 3 all the way up to 1. It's greater than or equal to 0.